Bienvenidos a Onyx Solar.
Welcome to Onyx Solar. I'm Michel Castellano from the Technical Department of Onyx Solar. During the next few minutes in this introductory course, we will see all our different technologies. We will see the different types of cells, transparency, connection boxes. Let's start this first part of the course explaining the different technologies that we have. We're going to start with the crystalline technology, the most well-known worldwide because we have all seen a solar garden or a roof with photovoltaic panels. The crystalline technology uses these types of cells. At Onyx Solar, we use different kinds of photovoltaic cells. In this case, this is the monocrystalline technology. Here, we see a sample of polycrystalline cells. The main difference is that the monocrystalline cells have these small cuts to cut impurities from cells. On the other hand, we have the polycrystalline cell, which is completely squared. Nowadays, the trend is using bigger cells in order to achieve greater efficiency. At Onyx Solar, we already work with these new cells, specifically 158mm cells or even larger cells with different busbar measures. Busbar are these connections that run through all cells that make a parallel serial connection. Within our photovoltaic integrated solutions, we offer colored cells. Here, we see a wide range of colors and cells that will allow us to customize our photovoltaic glass. At Onyx, we care about offering customized or tailor-made solutions. The different combinations of all these types of cells will allow us to offer a wide range of different solutions. These cells have different aesthetic finishings. Please contact our technical department about the different available colors. Now, we're going to explain in detail our product technology. Our customization starts with the separation of cells. We can separate these cells as much as we want. We have some limitations, though. Please contact our technical department. But we can separate them to a certain extent to provide the glass with different levels of transparency. In addition, we can choose the glass thickness. We will always be working on crystalline silicon technology, double laminated. In other words, two glasses adhered to each other. We can choose from among a variety of glass thicknesses, from a 4+4, 5+5, 6+6, 8+8 or 10+10, or even a 12+12. To adhere the glass, we use a material called EVA that gets melted inside the laminator. We will see that during the glass manufacturing process. We can also choose from different varieties of glass. Usually, for the first layer, we use a low iron or extra transparent glass to leverage the maximum efficiency of cells, so we avoid loss of energy due to the optical transmission. For the rear area, we also use tempered glass. I forgot to mention that for both sides, we always use a tempered glass so we have a secure glass. This is very important, especially when we're working with buildings. So for the rear area, we can choose from a large variety of finishes. To name a few, a glass treated with acid or with a black ceramic frit. The black ceramic frit basically is a glass painted in black. Later on, it's tempered. This provides the glass with a lifetime warranty and a great aspect because it combines the black cells with the black rear zone. That frit can be of any color. It doesn't have to be black, but it's the most commonly used at Onyx. These would be our main takeaways in regards to our crystalline photovoltaic glass. Another point, 4,000 by 2,000 millimeters are the maximum dimensions that we manufacture a crystalline silicon glass, that is 4 by 2 meters. Now we are going to explain in detail what a string is. A string is a serial cell connection. Our glass is made up of different strings. This case is a special module. It has a composition with rear glass treated with acid. Another advantage that our product has is its versatility in terms of shapes. Here we have a glass with a curved cut. We can also make triangular or trapezoidal cuts. Let's say that with crystalline glass, there are no limitations in terms of shapes. Then we see if they are active or inactive. Here we see 2 inactive glasses that we used in a real project to make a finish in such a way that the whole set had the same visual aspect. In addition to that, we can also mechanize. We can use spider-type systems. Virtually, we can do anything that is possible to do with conventional glass. Another point that we will go into more detail later are the type of junction boxes. Connections. In this case, this is a lateral connection, but we will explain this in more detail later and see all the possibilities because junction boxes are one of the key points when making a good photovoltaic integration. Still on the subject of crystalline technology, we're going to see some examples of different integrations that are very attractive and give an idea of the possibilities that our photovoltaic glass has. Behind me, we are seeing a photovoltaic glass with green cells and with a green frit on the rear area. In this case, we wanted to match the cell's color and the rear area with the same colors. That will allow us an integration in a roof or facade with a green color. Our goal is matching the photovoltaic glass with the same color that the roof or facade has, like a green roof or a green facade. Here we have another sample in terracotta color, or red, for an integration with roof tiles. In this respect, we want to reduce the visual impact of our photovoltaic glass. In addition, as previously mentioned, we also have photovoltaic glass with black cells and black glass for the rear area. This glass is spectacular when installed. The black finishings are very attractive. The concept for both glasses are the same, a colored glass for the rear area that matches with the cell's colors. In this case, we are seeing colored monocrystalline cells. We continue deepening our knowledge by talking about the photovoltaic glass complexities. We're going to continue with another example. We're going to explain another 2 possibilities with photovoltaic glass with crystalline technology. In this case, we are now seeing a photovoltaic glass with back contact cells. The particular feature of these cells is that they are smaller, a 5-inch cell. The cells we saw before were 6 inches or bigger. These cells have the particularity that there aren't any interconnection between cells on the front side. There is only one restriction. The distance between these cells cannot be changed. It's mandatory to have this connection between cells. However, we can change the distance between strings. Another important feature is these finishes. This rear area is fully colored. This glass has this blue tonality, which is really attractive. For these fully coloured areas, there is a range of colours. There are not many. Please contact our technical departments. It's a great way to customise photovoltaic glass. Here, you see different connections on this side. As I mentioned, later on we will see in more detail these types of junction boxes. Now we're going to explain the secondary technology that we offer at Onyx Solar. We are going to explain the amorphous silicon glass. This technology is outstanding because as a result we have see-through glass. This is the core advantage compared with the crystalline glass. We have different finishes. We go from the opaque glass to different levels of transparency. This one 20% and 30%. Regarding power regeneration, the opaque glass generates 58 watts per square meter. The one with 10% of transparency generates 40 watts per square meter. The one with 20% of transparency generates 34 watts per square meter and 28 watts per square meter for the one with a 30% of transparency. In regards to thickness, amorphous silicon glass has its own particularities. We usually work with a standard format that we manufacture at our factory. The size is 1245 by 635. With this size, we can do it in double laminate. If we exceed this size because we want a larger format like this one here, then we need to adhere to them. These are called sub-modules. This glass is made up of 4 amorphous silicon modules. In this case, this larger size is a triple laminated glass. I'm carrying a small sample, and here we see the 3 glass layers. The middle layer is going to be always 32 millimeters, because it's the one where the amorphous silicon is applied using CVD and PVD techniques. It's a very thin layer. Its thickness is less than 3 micron. By using these laser techniques, we achieve these degrees of transparency. We cannot change the thickness of the middle layer. It needs to be 32 millimeters. The front and back thicknesses can be modified. We can choose from 4, 5, 6, 8 and 10 millimeters. Then, as a result, we have different combinations like 4 millimeters plus 32 millimeters plus 4 millimeters, or 6 millimeters plus 32 millimeters plus 6 millimeters. The front and back glasses are always tempered glass. As we previously mentioned on crystalline silicon, we can combine different finishes for front and rear glasses. Preferably, we will always use a clear or extra clear tempered glass for the front glass. For the rear glass, we can also have the same possibilities. For crystalline silicon glass, to laminate we use EVA. For amorphous silicon, we laminate with PVP or Centi-glass. These are 2 different thermoplastic products with which we can obtain different properties. In addition, we have a third option. We can laminate with coloured PVP. Right behind me, we have some samples laminated with coloured PVP. For instance, there is a green sample. Therefore, we can customize amorphous silicon glass with a wide range of colours. Let's say that there are no limits. In regards to colour customization, please contact our technical department. Maybe there are some specific colours that are not available. As you can see with this sample, this glass is transparent and coloured. Its rear area is uniform, and the front side has a darker tonality. The coloured PVP always goes behind the photovoltaic layer, which will never affect the glass performance. In other words, its photovoltaic properties remain intact. Another technical aspect for amorphous silicon glass, it works very well with diffuse light. This means that during cloudy days or with non-optimal orientations, this technology works really well. Therefore, it's an optimal solution to be installed on facades. Not only it provides light transmission, but also it's effective for energy generation. Lastly, here are a couple of samples of amorphous silicon glass. In this case, we have a front glass treated with acids to get a frosted glass. A glass that doesn't have any glare. What is more, we have this other photovoltaic glass with a digital printing on the rear glass. With a front glass that has 30% of transparency, we can manufacture such an attractive glass like this one we see here. The glass is photovoltaic. It has an amorphous silicon layer with 30% transparency at the front, but it's barely visible. Another important point in regards to architectural integration, it's the possibility of integrating an air or argon chamber. This is very important for buildings to provide them with thermal insulation and get greater energy savings. At Onyx, we have the possibility to include an air or argon chamber into crystalline silicon or amorphous silicon glass. This air chamber would be exactly the same as the ones used for conventional glass. We can include air chambers or argon chambers, a single or double chamber. Its thickness can range from 10 millimeters to 20 millimeters. At Onyx, we offer all these possibilities. We can also include low emission glass into chambers and reduce the U level to low levels if necessary, like 0.6 watts per Kelvin square meter. Here you see a sample. In this case, it's a simple 12 millimeter chamber. And these are the finishes. Later, we will show you how to integrate the junction box in such a way that it does not visually affect the camera. We can even include a black frame. Therefore, there are a wide range of possibilities to achieve different insulation levels. The photovoltaic pavement is one of our star products, and it's already patented. We can walk over this photovoltaic glass. We can manufacture this photovoltaic pavement either with amorphous silicon glass or crystalline silicon glass. In this case, this photovoltaic pavement has a triple laminated amorphous glass, a combination of 6 plus 3.2 plus 6 with tempered glass. The front glass has non-slip treatment. This non-slip treatment is the best anti-slip treatment for glass available on the market. It even works when the glass is wet. With crystalline silicon glass, the composition would be 8 plus 8 with tempered glass, and we would also use the same glass with a non-slip treatment. Regarding building integration, one of the most important aspects are junction boxes. These boxes will allow us to make a better integration. We have different possibilities, and we can always adapt to our customers' needs. Among the possibilities, in this case, for crystalline glass, we have a conventional junction box placed on the rear area.
También dentro del silicio cristalino vamos a poder optar por una caja de conexión lateral.
It has a conventional photovoltaic module. For example, it could be placed in the glass perimeter, just like I'm doing right now. For skylights and curtain walls, this type of connection allows hiding these boxes. For amorphous glass, we have a similar option. The main difference is that it's smaller because the intensity is lower. We have a bipolar junction box with two cables, but we also have the possibility to divide the box in two parts and place each part on one side, one on this corner and the other on that corner. This will help us to simplify any installation and reduce the wiring or the internal connections inside the glass and for the whole photovoltaic installation. Furthermore, we offer side junction boxes as well for installations with amorphous glass. It's important to bear in mind that this type of box is very useful when using glass with a chamber, because there is no need to cut the chamber to place the box inside. In this case, we can directly place the box on the edge. This type of connection allows an optimal integration. Usually, for this type of solution, please contact our technical department. We can guide you about what is the best solution tailored to your needs depending on the project and type of photovoltaic glass. Still on the subject of junction boxes, in this case, this glass has a double argon chamber. This glass is normally used for Nordic countries because they require a high degree of thermal insulation. This junction box is a monopolar box. This is the positive pole and this is the negative. Here, we made a sort of box, also called an offset, with this specific shape. In that way, we created a space to place the box. With this solution, we are able to place the box on the edge, on the side, and on the back.